You might remember in this chapter we've been talking about sequences and series. Remember that a sequence is a list of numbers and a series is when we go back and add those numbers. Well, there's a more concise way that we can write a series, and that's with using a sigma notation. Now, sigma is this letter right here. It might look familiar from like sororities and fraternities because it's a Greek letter, but this is called sigma notation. This bottom number down here is called your lower limit of summation. Now, you don't have to know that, you don't have to write that down or know that. It's just so that when we use that in discussion or when they use it in WebAssign, that you know what they're talking about. So this lower limit of summation is where I'm going to start. I'm going to start by putting 1 in for I in my problem. So I would put in 1 and then I would put in 2 and put in 3 and I would keep going until I get to this upper limit of summation, and that would be the last number that I would put in. Then sigma means sum. So that means that once you found each of those terms, you would go back and add them. This letter could be any letter of the alphabet. It's called the index of summation. So we use an I here, but sometimes they'll use J or K or N or whatever you'd like to. So let's look at this first example. All right, so this first example says to find the summation of 3i. So you'll notice that we're going to start by putting 1 in for I, and then we're going to stop when we get to 5. All right, so I'm going to start by putting in 1, so that'd be 3 times 1, and then put in 2, 3 times 2, and then put in 3, and then 4, and I stop after I put in 5 because that was my upper limit. Nowhere on here are they going to say find the sum of this. Sigma means sum. And so that's what's going to tell me that after I find each of those products that I'm supposed to go back and add them. So if I go through and say 3 times 1 is 3, 3 times 2 is 6, 9, 12, 15, and I add those numbers together, I'm going to get 45. And so that would be a series again, because again, it's the sum of a sequence of numbers. So we said that a sequence is when you just have the list of numbers. A series is the sum of the sequence. It's when you add those numbers. So let's look at another example. Look at A right here, where they asked me to find the summation from 1 to 3 of 3 over 10 to the I. All right, so let's start with, I'm going to put in 1 for I, and then I'm going to put in 2, and then I'm going to put in 3. All right, so we put in 1, and then we put in 2, and then we put in 3. Another way that they could have asked me to do this same thing is they could have given me 3 over 10i, and they could have told me to find the third partial sum. The third partial sum just means the sum of the first 3 terms. So if this had been the fifth partial sum, then I would have just found the sum of the first 5 terms, right? So that's just another way they could ask me to do this. So 10 to the first we know is 10, 10 to the second is 100, and 10 to the third is 1,000. If I write it as a fraction, I have to get a common denominator. So I'm going to write it as a decimal instead. So 3 tenths, of course, is 0.3. 3 100ths, 0.03. 3 1,000ths, 0.003. So if I add those, I'm going to get 0.333 or 333 1,000ths. Now, the next thing that they asked me to do is they asked me to find the sum of that same sequence, but they asked me to find the sum to infinity. Great, so I'm just supposed to do this problem for the rest of my life, right? Like I'm just going to keep sitting here and plugging in 1, 2, 3, 4, 5, 6, 7, 8, and it just never stops. Well, there are very few sums that we can find the sum going to infinity. They have to have special conditions, and we're going to talk about those in just a little bit. But for this problem, let's do what we've already done, okay? So we already know when we put in 1, and then we put in 2, and then we put in 3. Let's keep going with that same pattern. We could put in 4, we could put in 5, 6, as many values that we need to. We also already saw that when we put in 1, we got 3 tenths. We put in 2, we got 3 100ths. We put in 3, we got 3 1,000ths. So if we put in 4, if we keep going with that same pattern, do you see how every time it's just adding a 0 after the decimal? So that basically this next one would be 0.0003. And so once we recognize that pattern, just like we said with our terms, you don't have to keep using the formula once you recognize your pattern. If I go through and I add up 0.33333, do you see that's just going to be 0.3 repeating, or 1/3? So again, there are very few things that we can find the sum going to infinity, but this is one of those things that we can. I don't know about you, but infinity is something that's really, really hard for me to comprehend. Everything in my life has a deadline, has a due date, has an ending point. And so I have a hard time thinking of something that just goes on and on and on forever. And the other thing that makes me think of that is eternity. And so the same thing, like it just boggles my brain to try and think of we are going to live forever without end in either heaven or hell. And it is so important that we make that decision. If you have any questions at all about that, I would love nothing more than to talk to you about that. It is the most important decision you're ever going to make. Additionally, we have what, about 80 years on average to prepare for all of eternity. So, what am I doing today that's really going to make a difference? The stuff that I'm worrying about today, like, is it even going to matter a week from now, or a year from now, or 50 years from now? Like, what can I do today that's going to matter for eternity? Just kind of helps me reprioritize a little bit when I think along those lines. All right, grab your graphing calculator if you would, please. I want to show you that you can get your calculator to do your sigmas as well. All right, so on your calculator, depends on whether you have the 83 with the old operating system or the 84, but I think the majority of you have the 84 with the new operating system. So let's look at this one. All right, so what we're going to do then is we're going to go to alpha window. So when we do alpha window, we're going to pull up this menu and see this number 2 right here. It might say summation on yours, or it might say sigma. Hit that and look, it puts this cute little thing on your screen, right? So that's a happy thing. This flashing A right here stands for alpha mode. So it'll take whatever letter you put in. You can use any index of summation here that you want to. I used I just because that's what we used in our problem, but you could use X or N or J or whatever you wanted to. Then this is going to be that 1, that lower limit of summation. This was our 3, our upper limit of summation. And then this was our formula, which was the 3 over 10i. So again, this is that same problem we just did a moment ago when we did the third partial sum. All right, so sure enough, whatever variable I used here, I need to use the same one here. So however you did this, do the same thing here. And you'll see that it's giving me that 333 1,000. Same thing that we got when we worked it out by hand. All right, so we've already talked about the fact that we have arithmetic sequences and series. That if we went through and we found a constant difference, that would be arithmetic. Today we want to look at geometric sequences and series. And the way that we can tell if something is geometric is, instead of does it has a common difference, we want to know does it have a common ratio. And the way we find that is we take the second term and divide it by the first, third term and divide it by the second, fourth term and divide it by the third. So when we do that, if we get the same answer every single time, that is our ratio, and that means that it will be geometric.